Let's take a look at a few examples of factoring a special form, specifically the sum or difference of two cubes. The rules that we have are basically the same rule, just with some sign changes because of it being a sum or a difference. If we notice, when we have a sum of two cubes, now these have to be perfect cubes, and what I mean by that is some base, in this case it's a, raised to the third power. It could have a coefficient, but that coefficient would have to be a perfect cube. In this case it's 1. It could also be 2 to the third power, which is 8, or it could be 3 to the third power, which is 27. So I could have 27a cubed, and that would still be a perfect cube. I factor that into a binomial times a trinomial. The binomial, the terms in that binomial, are the base of what was raised to the third power in the problem. So our problem is a to the third, so my base was a, and that's what is the first term in my binomial. Notice the sign in the binomial is the same as the sign in the problem. In the trinomial, we have the first base squared, or to the second power, minus the product of the two, plus the second base squared. Okay, notice that the last sign in both rules is always the plus. The middle sign is the opposite of the first. So your rule for sign is if you have a sum, the sign in the problem is a plus, so the sign in the binomial is a plus. The next sign is a minus, that's the opposite. The last one is always a plus. In a difference, the sign in the problem was a minus, so my first sign is a minus. The middle one is the opposite of the first. The last one is always a plus. And I'm going to show you a little trick as far as remembering what goes in this trinomial when we actually do some problems. So let's take a look at some problems now. Okay, let's take a look at two problems. In this first problem, we have x to the third power plus y to the third power. We know those are both perfect cubes. So we think about how to write that first binomial. We know that in the binomial, the base of the first term is my first term in my binomial. So I have an x here, because that's what's to the third power. The sign always matches. The base in the second one was a y. Okay, to get the terms in my trinomial, I can think about the rule and just memorize that and say, okay, the first term is the first base squared. Or I can do this little trick where I just write x times x times x, y times y times y. Okay. Basically, I took the first term in my binomial, wrote it 3 times. The second term in my binomial, wrote it 3 times. I pair these up, and I say, okay, x times x is x squared. X times y is xy. Y times y is y squared. My last sign is always a plus. The middle sign is the opposite of the first. So in this case, that's a minus. And that's kind of messy. This part is not part of your answer. That's just our little cheat sheet that helps us get the right thing in there. The answer is the binomial times a trinomial. Okay, so this part's your answer. I can't factor that trinomial any further, so you don't need to even try. When you use that rule, you know it's not factorable any further. Alright, let's look at the next one. We've got x to the 6th minus 8y to the 3rd. So the first thing we have to do is say, okay, is this a perfect cube? Well, yes it is, because if I think about x squared times x squared times x squared, that gives me x to the 6th. So the base of that would be x squared. It's a minus, so I put a minus. Is 8y cubed a perfect cube? Yes, it is, because 2 to the third power is equal to 8. Y to the third power is y, so my base is 2y. And if it helps you to write an extra step in here to say, okay, so that means I have x squared to the third power, and that's equal to x to the 6th, which is what I had. That way I can look at that and know that my base is x squared. Here we did that with the 2, but if we think about 2y to the third power, that's equal to 8y cubed. So I know, yes, 2y is my base. I don't have to worry about the sign because remember the rules for the sign are separate. The first sign matches what was in the problem. Then to get the trinomial, I'm going to say x squared. I don't know why my pen is having a hard time with exponents. X squared, because remember when I use my little trick, I write the first term in the binomial 3 times. Then I write 2y, 2y, 2y. I don't use the sign because we're doing signs separately. I pair these up. Say, okay, the first two go together, the middle two go together, the last two go together. X squared times x squared gives me x to the 4th. X squared times 2y gives me 2x squared y. 2y times 2y gives me 4y squared. My original sign was a minus, so my middle sign is the opposite of that. It's a plus. The last sign is always a plus. This is not a part of my answer. So my answer is the binomial times the trinomial. Again, I don't need to try to factor that any further. The only thing that could make something be wrong there that I would need to look at factoring further is if I had a common factor in there that I didn't factor out at the beginning. But I don't think that's going to happen in perfect cubes. Okay, let's look at a couple more examples. We've got 6x cubed plus y cubed. We're thinking sum of cubes. But it's not a sum of cubes because I have a coefficient of 6 and 6 is not a perfect square. If I want to make a list, I can think about 1 to the 3rd power is 1. 2 to the 3rd power is 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64. And 6 is not on that list. So 6 is not a perfect cube. These two don't have anything in common, so I can label this as prime or non-factorable, whatever you want to call it. That just means we can't break that down. We can't factor that in any way. Now let's look at the next one. We have an a to the 3rd power. We have a b to the 9th. We know if our exponent is a multiple of 3, then that term, the b to the 9th, is a perfect cube. So now we have to think about 16 and 2. No, 2 is not a perfect cube, but 2 and 16 are both divisible by 2. So if I start by pulling out the 2, that leaves me a to the 3rd minus 8b to the 9th. Then I can say, all right, they had a 2 in common. I took that out. Now I look at what's inside the parentheses, and I do have a difference of cubes. So I keep my 2. I can't get rid of any factors. I think about what goes in my binomial. A to the 3rd power, I know the base is a. All right, now this one's a little trickier, so you may want to go over here and think about what you've got. We know that 2 times 2 times 2 is equal to 8. We know that b to the 3rd times b to the 3rd times b to the 3rd is equal to b to the 9th. So we know that 2b cubed to the 3rd power is equal to 8b to the 9th. So my base is 2b to the 3rd. So my first sign always matches up, so it's a minus. My base was 2b to the 3rd power. To get my trinomial, I look at my first term in the first set of parentheses and I say a times a times a times 2b to the 3rd times 2b to the 3rd times 2b to the 3rd. I pair those up. First two go together, middle two go together, last two go together. I get a squared. My next sign is going to be a plus because my first one was a minus, and the middle sign is always the opposite of the first. A times 2b to the 3rd is 2ab to the 3rd power. The last sign is always a plus, and I get 4b to the 6th power. This is not a part of my answer. My answer is 2 times the binomial times the trinomial. Okay, I hope that helped with factoring cubes. If you don't like the little trick where you write things down and you can just remember to square the first base, the product of the two, square the second base, that's great, and there's nothing wrong with doing that. This is just something that helps me visualize it a little bit. For some people, that's easier than just remembering or writing down the formula and plugging that in.